Today we're going to tackle differential calculus. We're going to begin in derivative introduction and its rules, and then implicit differentiation. We're also going to answer one real-life problem involving derivatives to understand its application, and alas, discuss higher-order derivatives. Whew! That's a number of activities, yes? Without further ado, let's get down to brass tacks!
Today, let's discuss about rules in differentiation. But first, what is derivative? Well, derivative is an important limit. It is the computation of a slope of a tangent line and the instantaneous rate of a change of a function. That is derivative.
The definition of tangent is given by limit of f of x plus h minus f of x over h as h approaches 0. That's why the derivative is given by f prime of x is equals to limit of f of x plus h minus f of x over h as h approaches 0. If we're going to use the definition of derivative in computing the derivatives, it's going to take long. We can use the rules of differentiation in finding derivatives of a function, which is already proven and tested. Now, we're going to find the derivatives using the rules in differentiation. Number 1 is constant rule. F of x is equals to k, where k is any real number. Then f prime of x is equal to 0. Example, f of x is equals to 10. Then f prime of x is equals to 0. Another, f of x is equals to 794. Then f prime of x is equals to 0.
Next, we have rule number 2. Constant times a function. As f of x is equals to k times any function, where k is any constant number, then the derivative of f of x is equals to constant multiplied to the derivative of any function. For example, f of x is equals to 3x cubed. The constant 3 is multiplied to the derivative of the function x cubed, where we should apply power rule. Then, f prime x is equal to 9x squared.
Product rule. F of x is equals to g of x times derivative of k of x plus g derivative of x times k of x. For example, f of x is equals to 2x squared plus 4x times 3x squared plus 5. Then, we're going to apply the product rule. G of x times k derivative of x plus g derivative of x times k of x. Then, we're going to distribute each 6x times 2x squared plus 4x plus 3x squared plus 5 times 4x plus 4. And we're going to get 24x cubed plus 36x squared plus 20x plus 20. Quotient rule. For example, f of x is equals to 2x squared plus 3x over 3x squared plus 4. Then, we're going to follow the quotient rule. K of x times derivative of g of x minus derivative of k of x times g of x over k of x squared. Then, final answer is 16x plus 12 minus 9x squared over 3x squared plus 4 squared. Chain rule. For example, f of x is equals to f times 3 plus 6x raised to 3. We're going to apply the chain rule. N times u raised to n minus 1 times derivative of u. And the answer is 72 quantity 3 plus 6x squared.
So what if the function is written implicitly? Well, you could write it explicitly first. Like for example, x squared plus y squared is equals to 25. Y squared is equals to 25 minus x squared. Then y is equals to positive or negative square root of 25 minus x squared. Now, we have written its explicit form. We can find the derivatives now. But let's move on. Let's solve one example. 3xy plus 4y is equals to 7. The function is not written explicitly. So, we should find its implicit form first. From the first term, 3xy, we get 3x dy dx plus 3y. We use the product rule here. Now, we get the second term, 4y. 4 dy dx. Now we get the third term. 10 is equals to 0. Oh wait! 7 is equals to 0, rather. But don't panic, it's okay. We're still following constant rule, right? Remember? Now we combine it. 3x dy dx plus 3y plus 4 dy dx is equals to 0. Now we factor it out. 3x plus 4 multiplied to dy dx plus 3y is equals to 0. And then we subtract 3y to the both sides. And then divide 3x plus 4 to the both sides too. And finally, we get y prime is equals to negative 3y over 3x plus 4. Now, we're going to solve one real-life problem using derivatives. The cost in dollars of producing X gallons of wood stain is given by the following function. C of X is equals to 0.0004x cubed minus 0.001x squared plus 0.1x plus 3,200. The problem is, what is the instantaneous rate of change of the cost when 100 gallons are produced? Oh, we're looking for marginal cost. What is marginal cost? Marginal cost is how much the function increases as input or quantity increases. Now we're going to the solution. First, we find the derivative of the function. We get c prime of x is equals to 0.0012x squared plus 0.002x plus 0.1. And then, we substitute 100 to the x. We get 12 minus 0.2 plus 0.1. And finally, we get the answer, which is equal to 11.9. $11.9 per gallon. C of x is the cost in dollars for x gallons. Therefore, its rate of change is measured in dollars per gallon. In conclusion, the instantaneous rate of change of the cost when 100 gallons are produced is $11.9 per gallon. The rate of change is positive because cost is increasing. By solving high-order derivatives, let's use this example. Y is equals to 3x raised to the power of 5 minus 2x. Then, we get its derivative using the rules of differentiation. Y prime is equals to 15x raised to the 4th power minus 2. Then we will continuously use the rules of differentiation until we get the desired number of derivatives. You know, you can pause the video to carefully assess the solutions. Now we're done! Easy peasy, right? I hope you ace your exams. What time is it? I need to sleep already. Goodbye till our next tutorial!